Okay, welcome back. This section is section 1.2, estimation. There's a lot of reading on these notes, so I may not read all of this narrative to you, so please do fill in whatever I don't read out loud. I'm going to hit the high points of it though. The main thing I want to talk about is rounding. This is a question I get a lot of times. It might not be something that you do like every day, and you may have forgotten kind of the details of your place values, so I want to go over that with you. So the decimal point divides our kind of units that we talk about. When we look to the left side of our decimal point, we start with the ones place. Ones, tens, hundreds, thousands. Then it would be 10,000s, 100,000s, millions, 10 millions, so on and so forth. We won't use those great big numbers like that, but it just continues that pattern. And there's infinite amount of numbers, so there would never be an end to this list, but it keeps going. Then you have 10 millions, then 100 millions, then you go up to billions, then 10 billions, 100 billions, then trillions, and so on and so forth. But the main thing is to notice there is no TH. It just starts with ones, then goes tens, hundreds, so on. When we go behind the decimal point, to the right of the decimal point, there is no once place, just to note. It starts with tenths. So that's something that you need to be aware of. So behind the decimal point, we start with tenths, and it has a TH on the end. Then we do hundreds. Then it's pretty much the same pattern, but notice that it has a TH as we go back behind the decimal point. So we have some examples here, and as always, I ask you to pause the video to do the activities and then come back in, and then I'll go over the answers with you. So do that as needed. But I want to practice some rounding with you. So again, read all this. There is another type of rounding that you need to be aware of, and there's a handout in your Blackboard shell called Significant Figures. There are some other industry type of rounding rules so that you don't overcompensate too much by this rounding up with the 5 and down below 5, which we'll talk about. But just be aware, and you do need to read that handout and be aware of it. But most typical math books, standard math books, go by the rule that if it's a 5 or more, we round up. If it's less than 5, we round down, or we leave it off. So that's what we'll be going by, the standard rounding rule that you see in your notes here. So in the activity 1, each one of these says round to tenths and tens to practice it. So we'll practice both of those, 8, 9, 8. We're going to round it to tenths as well as tens place. All right, so tenths place we know is right after the decimal point, so that would be this 8. So we found the place that we're rounding to. We look at the number after it. If it is 5 or more, we'll round that number up. So yes, it is, so that rounds up to a 9. So you write the 642.9. For tens place, tens, over here, that's ones, that's tens. The number after it is less than 5, so we will change that, round that down to a 0. So we make that 640. So we round that down. And okay, number 2, 736.754. First of all, to the tens place. The tens place is the number right after the decimal point, the 7. The 5 says yes, round that up, so that rounds up to an 8. So we have 736.8. When we round it to tens, when we're rounding up in here, we just put zeros in for the places. You might have noticed that in the example before. Here we put specific numbers. But anyway, so tens place is the 3, and the 6 would say yes, round that up to a 4. So we'll make that 740. And we just fill in zeros back to the decimal point. So the nearest tens place, 740. Okay, number 3, 23.234. Tenths place, that would be this 2 right here. The 3 says don't round up, so we leave all that off and just leave that as it was, 23.2. And we don't fill in these zeros. They're not significant zeros. We only fill in zeros to get back to the decimal point or to show the place value we rounded to. So that would be sufficient. Okay, to tens place, this 2 is in the tens place, so the 3 says don't round up, so we put 2, 0. 20 is the nearest tens. Number 4, 491.987. The 10th place with the TH is the 9. The 8 says yes, round up. Okay, so this one's got a little different twist to it, so we'll pay special attention here. The 8 does round that up, but the number after 9 is 10, so it carries over into the ones place. So it makes that a 0 and rounds that up to a 2, making it 492. Now I will put the 0.0 because that shows that I rounded to 10th place. So normally zeros don't matter after the decimal point. They're not significant normally, but in this case it shows the level of significance that we rounded to 10th place. So I would show that. It wouldn't be absolutely wrong or change its value if you didn't, but here where we're trying to look at precision and what we rounded to, it's nice to see this was rounded to 10th place. All right, the next example to the tens place is this 9. Now, this 9's in the tens place, so the 1 would not round it up. I'm doing too many where we don't round those up. Seems like over in the tens place. So it leaves it 490. And again, we always fill in the zeros back to the decimal point, so that is important. On the next page, we have a reading problem where we talk about estimation. There is no absolute way to estimate. Sometimes we estimate more loosely depending on the place value you're asked to. So when you do your homework, it should specify the decimal place that's the place value that you need to round to. So, if you're in a store and you want to get an estimate of your checkout, it's good to have kind of a mental idea of what things should add up to. So in this example, Jean decides to purchase new textbooks for her elementary school library. She's purchasing 19 books at $3.99 each. That one's maybe a little more obvious. Sometimes, the examples we pick are kind of more obvious than in real life. You may have more decision to make there. But probably I would say, hey, let's just call that 20 books and about $4 each, $3.99. So close to $4, right? So in my mind, I know it should be about $80. So that's a pretty easy estimate there. Sometimes it's more complicated than that, and I know you know that. So sometimes it's not quite so obvious, and you need to decide what you're going to round to. Whether a whole dollar, and it depends on how quickly you've got to estimate in your mind. So again, I've got some examples there. You can look over that. The next thing I'm going to jump to is number 3, and we're going to talk about filling up your gas tank and finding your miles per gallon. This is a fun problem. Something good to know is how you're doing on your gas mileage, which I know now everything's probably digital and you just know from your readout on your screen, but back in the day we used to figure this out by hand, and you'll have some questions in your homework like this. So to figure out MPGs, which would be miles per gallon, the word per in algebra usually means divide, so it means miles divided by gallons. So what you want to do to get a good estimate of your gas mileage is you want to try to get a full tank of gas, run that tank of gas out as close, don't go too far, but run it out pretty good, and then fill it back up and see how many gallons it will hold, noting your miles on your odometer each time, and then see how much gas you buy. So I show that procedure here, and how that you can figure out your exact gas mileage. So again, you fill your gas tank up as completely as possible, noting the odometer reading. So you're going to write that down somewhere. And in this one I did, for an example, 38451.4 miles. Then you drive that tank of gas out and you fill it up again. So note how many gallons of gas we bought, 2.6 gallons. And what your odometer reading is at your fill up. In my example, it's 38687.0. So you want to subtract these two numbers, and I've got them actually upside down, so it'll come out negative. But rearrange that, subtract that to see how many miles you drove on that tank of gas. In this case, it was 235.6 miles on that tank of gas, and I bought 12.6 gallons. So again, it's miles divided by gallons. So there's my miles I drove divided by my gallons, 12.6 gallons. So again, that makes it miles per gallon. So when I do that division on my calculator, it does give me a nice number of 18.698, or about 18 and a half miles per gallon. And I'm getting on my, for my car. So you can do this with an estimation. Of course, this section's about estimation, but you might want to know that one exact to get kind of a challenge to know how you're doing. Then I have some activities for you to do. So again, pause the video and practice this skill below, activity 5 and 6. So in activity 5, I would subtract the 53251 and the 52992 readings. I'll do that subtraction. Oh, this is dangerous here without my calculator. 2, 0. Okay, 259 miles. And then we bought 15.9 gallons of gas, and I don't have my calculator on me to check. Let me see if I can grab one real quick. I should have done that. Okay, 259 divided by 15.9. You should have got 16.289-ish miles per gallon on that activity. And then on number 6, I just think it'd be good for you to practice that and do your own, if you're curious, to do your own miles per gallon in your specific vehicle. On the next page, an estimation technique is with drone pictures. They're able to take aerial photos, and I know drones are such a bigger thing now, more common. They're taking aerial photos and able to estimate populations and help them with crops and all kinds of different things. So there's some in your textbook, you'll notice some photos taken from the air, and they use that technique then to divide it into equal squares. For example, they do a kernels of corn example. So if you'll notice that in your textbook, without me drawing it up here, there is one there where they grid it out into 20 equal grids, and you count the kernels of corn, and then you can kind of get an estimate about what's happening overall. They do that with trees, with livestock, with crops. So that's becoming a more useful technique, and it is based in on math with the estimation idea. And this is if you just ever are at the counter, a checkout counter, and they're asking you to guess the number of jelly beans in a jar, you can use this same technique. It's the same idea. You grid something off. So if they've got a great big jar of jelly beans at the counter, whatever, then if you can count, kind of maybe use your finger to figure out how many equal rows there are, then count how many are in the one row. The same idea of the aerial photos, you can multiply by how many rows you've got and get a good estimate. That's another estimation technique. And then I asked you on the activity to look in your textbook and see if you can kind of see what I'm talking about here, since I didn't get a good picture drawn up here. Another activity with estimation is tipping. So I go through kind of the tipping ideas here, 10%, 15%, and 20%, and just how you can get a good estimate with percents. A 10% is a real easy technique. If you had a bill that's $43.20, 10% is always just move the decimal one place. So 10%, because the decimal values are based on tens, so 1 decimal point would make that 4.32. So that would be your 10% tip. If you're 20% tip, you can just double that. Just double it in your mind, and you can be looser with that and say 4 times 2, $8 to get a good estimate of that. So I'll go through some of that, and then I ask you to practice some on the below. So I'll do activity 8 and 9 with you. You pause the video. So for the first one, I'd move the decimal one place. We're going to do a 15 and a 20. For that would give me the 10% is, I'm going to go ahead and round that to 69. That would be a 10% tip. Doubling it to get 20%. Let's see, that'd be, you just use your calculator probably, wouldn't you? 13 carry the 1. It'd be about $23.38 is your 20% tip on that one. And then on the next one, I would move the decimal one place to get 5.40 is my 10%. Double that to get 20%, so it's going to be $10.80 80 cents for the 20%.